Can everyone hear me and see the screen? Okay, so we will just go over the exam today, and your grade should be out either tomorrow or over the weekend. Okay, so here you have which of the following statement represent the negation of if x, y is odd, then x is odd and y is odd, and y is odd. So you know this is an if-then statement. If-then statement means this is an implication. So you have P implies Q. So you have if x, y is odd, then x is odd and y is odd. So we know this is a P implies Q statement. And the negation of P implies Q is congruent to P and not Q. So if you write the P and not Q statement, P represents x, y is odd. Now you have an N, then you have not Q. So you need to negate the Q. So to negate the Q, you need to have x is even. And to negate the N, you will have or. So the correct answer choices will be x, y is odd, and x is even or y is even. Any questions here? Okay, so here we have P is false, Q is true, and R is true. Now it's asking which of the following evaluation is true. So if you look at the first one here, you have negation of P and Q implies R. So you have P is false, so you have false and true, and false and true, that will give you false. So negation of false will be true, and you have true implies true, and we know this is true. So this is actually the correct statement. Now, if you check the other one, let's say you have P or Q implies not R. P or Q, if you look at the P or Q, you have false or true, so that means this is true. And then you have true implies negation of R, so true implies false. This is false. right? So the only time implication is false if your hypothesis, if your P is true and then your Q is false. Okay, next one, if you look at not P implies not Q and R. So not P is true. You have implies not Q will be false and true. So we have false and true that will imply false. So again, you have true implies false. So it's false. Next one, you have P and Q if and only if R is true. P and Q is false since one of them is false. You cannot have false if and only if true. They need to be both true or both false in order to be true. And next you have P if and only if Q and R are both true. So this is true. So again, you have false if and only if true. So this is false. And then you have P if and only if Q or R. Again, Q and R both true. So have Q or R, that's still true. So you have false if and only if true. So that will be false. So only the first one is true. Any questions here? Okay, so this is a proof question. So it asks you to prove that one of any three consecutive integer is divisible by 3. Right now, I give you a hint. You can write any integer as 3k plus r, where k and r are both integer and r represent the remainder of n divided by 3. Right, so if you look at it, right, so first you want to have 3 consecutive integers. So let x plus 1 x plus 2 be 3 consecutive integers. Now we can write x as 3k plus r. Right, again, where k and r integer and r is the remainder of x divided by 3. Now, if r is the remainder of x divided by 3, what can r be? What are the possible r value? Okay, so people say 0, 1, 2. Right, so the possible remainders when we divide it by 3 are 0, 1, and 2. So we can do approved by cases. So the case 1 will be when r equals to 0. Now when r equals to 0, x will equal to 3k plus 0, which will just equal to 3k. Now if x equals to 3k, what do we know? X is divisible by 3. Right, which we find one of the 3 consecutive integers are divisible by 3. Now case 2, we have r equals to 1. When r equals to 1, x is equal to 3k plus 1. Now if x equals to 3k plus 1, then x plus 2 will equal to 3k plus 1 plus a 2. Right, since this is your x. X is equal to 3k plus 1. Now when you add 2 to it, you will get 3k plus 3, which give you 3 times k plus 1. Now what does it tell you? X plus 2 is divisible by 3. Now case 3, your r equals to 2. Now when your r equals to 2, your x will equal to 3k plus 2. Then you know x plus 1 will equal to 3k plus 2 plus 1. And again, you get 3k plus 3, which can be written as 3 times k plus 1. And this is divisible by 3. So you know x plus 1 is divisible by 3. So what do we know? Right, so here we checked that for every cases, we found one of the 3 consecutive integers that's divisible by 3. So that will be approved. So this will be approved by cases. Any questions here? Okay, for the read and response, there is partial correlate. It depends on how you answer and then see on how close is your answer in the right track. I people asking what about the 0, 1, 2? That's the possible remainder when you write the 3k plus r. When you divide a number by 3, you can get 0 as a remainder, 1 as a remainder, or 2 as a remainder. And remember that we're writing x as 3k plus r, and r can be 0, 1, or 2. So if the remainder is 0, that means x itself is divisible by 3. Now, if x is not divisible by 3, that means it can have remainder of 1 or remainder of 2. So if x have remainder of 1, then x plus 2 is divisible by 3. If the remainder is 2, then x plus 1 is divisible by 3. So no matter what consecutive number you have, your first number will be one of the 3 cases. Then you can always find a number that's divisible by 3. Good? Okay. Okay, so this is an induction question. So we know for induction, we will always start with the basic step. Now your n is a positive integer, so your n will start with 1. Now your n is 1, so you want to check is 2 times 1 factorial greater than 1 factorial times 1 factorial. Now 2 times 1 factorial is 2 factorial. That will just give you 2. So that will just give you 2 is greater than 1. So we know this is true. Then we move on to the inductive step. So the first thing in the inductive step, you will make inductive hypothesis, which you will assume two k factorial is greater than k factorial times k factorial. For k, it's positive integer, so for k greater or equal to 1. And then you want to show 2k plus 1 factorial, right, 2 times k plus 1, it's greater than k plus 1 factorial times k plus 1 factorial. So if you start with 2 times 2k plus 1, or 2 times k plus 1 factorial, you can write it as 2k plus 2 factorial. Now, normally you want to rewrite it so the term in the inductive hypothesis appear. So you write it as 2k factorial times, and you can have 2k plus 1 and 2k plus 2. So that will give you 2k plus 2 factorial. And you want to show this is greater than k plus 1 factorial times k plus 1 factorial. Okay, so we know by inductive hypothesis, this is greater than k plus 1. This is greater than k factorial times k factorial times 2k plus 1 times 2k plus 2. Right, since 2k factorial is greater than k factorial times k factorial, that's from the inductive hypothesis. Now, if we look at it, we know that $2k plus 1 are greater than k plus 1. 2k plus 2 are also greater than k plus 1 for k greater than 1. Then we know what we have earlier, but we know this will be greater than k factorial times k factorial times k plus 1 times k plus 1. Since 2k plus 1 here is greater than k plus 1, 2k plus 2 is also greater than k plus 1. Now, if you look at it, k factorial times k plus 1 give you k plus 1 factorial, and you have another k factorial in k plus 1. So that will give you k plus 1 factorial times k plus 1 factorial. Right, so we show that 2 times k plus 1 factorial will be greater than k plus 1 factorial times k plus 1 factorial. And that's what we're trying to prove here. Any questions here? Okay, let's move on. So if you look at this example, 1q plus 2q plus 3q up to nq equals to n to the fourth minus nq plus 1 for positive integer n. And we know this statement is false, and we show it through counter example. Right, when n equals to 3, this is false. If you recall that in class, we check when n equals to 3, so you have 1q plus 2q plus 3q, and you check that 3 to the fourth minus 3 cubed plus 1, so you have 1 plus 8 plus 27, and you have 81 minus 27 plus 1. So I think here you will get 36, and then the right hand side you will get 55, and they are not equal to each other. So this is example we did in class. Okay, so here you want to prove that if x, y is even, then x is even or y is even. So there are different ways you can prove it. So if you proved, you can either prove by contrapositive, which means you will rewrite the statement. So you will have if to negate the q. So you have if x is odd and y is odd, then xy is odd. So to do that, you will write x as 2k plus 1, where k is integer. And you will have y also as 2q, let's say plus 1. You need to change your variable, right? So you need to use different variable for x and then the y. And q is also an integer. Then you want to show x times y is odd, so you will multiply 2k plus 1 with 2q plus 1. So that will give you 4kq plus 2k plus 2q plus 1. And you can write that as 2 times 2kq plus k plus q. And then plus 1 at the end. And we know this is odd. So we prove that this is true. Now, besides the prove by contrapositive, you can also prove by contradiction. Which you will assume the negation of it, and the negation of this statement is assume xy is even, and you will negate the q part, right? You have p and not q, so you need to negate the q part. So you have x is odd and y is odd, and then your goal is to contradict the assumption. So we can let xy be two odd number. So let x equals to 3, y equals to, let's say, 5. So x and y are both odd. Now, but if you look at x times y is equals to 3 times 5, that will give you 15, which is odd. We find a counter example. So we know it contradicts that xy need to be even. So the original statement is true. Okay, so there are two ways you can do it. So either you do it by contrapositive or do it by contradiction and provide a counterexample. Any questions? Okay, next. So here you have P is true, Q is false, and R is true. And now you want to find which of the following expression is false. Okay, so if you look at the first one, you have negation of P and Q or R. So P and Q, you have true and false, so you know you have false here. So negation of false is true, and then you have true or true, so that will give you true. So the first statement here is true. Now, if you look at the next one, you have P or Q and R. So you have true or false and true. Now, if you look at it, you have true or something else, then it's always true. So the second was also true. And then you have P and Q or R. So again, P is true and false or true. We have false or true. This is true. So you have trues and trues. That will also be true. And then the next one you have P or Q or R. So you have trues or false or true. So as one thing is true, it's true. Right, since it's all the true relation. Next you have P or Q. P or Q. So you have true or false. That's true. And then you negate it, you have false. You have false and true. So that will be false. And then the next one have P and Q or and R. So we have the or and relation as a form that is false, it will make it false. So the inside is false. When you negate it, it will become true. Any questions here? Okay, here you have a true false statement. You have if 2k is odd, then k plus 1 is even. Right, so we know this is true. Right, because we know even and odd off by 1. So if this is true, right, if this is true, then 2k plus 1, it is even. So this is true. Now, if this is false, if the 2k plus 1 is not even, if 2k is not odd, then the statement itself is true. You don't need to keep going. So this statement is true. Okay, so here is the domino question. So here, let's say you want to use mathematical induction to prove that if you line up the domino and then knock them down, you want to show all the domino will fall. So you know there will be part where you need to show if n's domino fall, then n plus 1's domino fall. Right, so that's the inductive part, inductive step, where you assume the kth one, right, or here the nth one false will carry the next one to the fall. And it's asking what's the base case. Now for the base case, it's always you prove the very first case, like the very first example, like value in your parameter is true. So when you line up a domino, your base case will be the very first domino is fall. Like someone is knocking it down. So you need to show that the first domino is fall, nothing else. You don't need to look at the relation between the first domino and the any other one. Since the base case, you manually check it. But you don't check any relation between the first one and then the next one. Right? So that will be done in the inductive part. So the base case or the base step is always the very first case. Okay, so here you have if and only if statement. So for if and only if statement, you need to prove P implies Q and Q implies P. Right. So for this question, if you break it down, you need to show if (3x squared minus 4x plus 5 is even, then x is odd. So you need to prove that, and you need to prove that if x is odd, then 3x squared minus 4x plus 5 is even. Right, so you check left implies right and right implies left. Now for the first part to show this is true, you can do a proof by control positive. Then you can rewrite it as if x is even, then 3x squared minus 4x plus 5 is not even, so odd. Now to do that, you have x is even, so you let x equal to 2k, where k is integer. Then 3x squared minus 4x plus 5 will give you 3 times 2k squared plus minus 4 times 2k plus 5. And that will give you 3 times 4x 4k squared. And then minus, you have 8k plus 5. And 3 times 4k squared, that will give you 12k squared minus 8k plus 5. And you can write it as 2 times 6k squared minus 4k plus 2, but you have 5 there, plus 1. So you can write as 2 times something plus 1, right? 5 you can write as 2 times 2 plus 1. And this is odd, right? So we show that if x is even, then 3x squared minus 4x plus 5 is odd. Now next we need to show if x is odd, then x squared minus 4x plus 5 is even. So you have 3x squared minus 4x plus 5 equals to, for x is odd, again you will write x as 2k plus 1, where k is an integer. Then you will have 3 times 2k plus 1 squared minus 4 times 2k plus 1 plus 5. And then you will have 3 times 4k squared plus 4k plus 1 minus 8k if you distribute the full, you can minus 8k plus 4, and then you add the 5. And this will give you 12k squared plus 12k plus 3 minus 8k minus 4, where you distribute the negative sign, plus 5. And that, if you combine the like term, that will give you 12k squared, you have 12k minus 8k, so plus 4k. And then you have 3 minus 4 negative 1 plus 5, so yeah, plus 4. And you can write it as 2 times 6k to the squared, and then plus 2k plus 2. So this is even. Right, so we show that left implies right, and then right hand side implies the left hand side. Good. Okay, next it's asking, there exists a real number x such that 120x is less than y for all positive real number y. So is it true? Can you find a x that it will be true for all can you find a real number x when you multiply 120, it will be strictly less than all positive real number y? Yes. And if you say yes, can you give an example of x? Yes, 1x for all y. Again, your x is all real number, right? X is just a real number. Right? So you want to find a real number x that will work for all positive real number y. Can you find a number that's that's smaller than all positive real number? Anyone? What is all the positive number? Like, can you give me an example that's smaller than all the positive number? Yeah, so this question is, there exists a x for all y, 120x is less than y. And again, y is positive. Right? Y is all positive real number. And x could be anything. Right? So we can let x to be any negative number, right? Or 0. Right? All the positive is greater than 0. So this is true. You just let x to be 0 or some negative number. Okay, next. For all positive integer n, is it true that 120n is greater than n to the 120? Now here the answer will be no. Right, so if you look at that, when n is small, then this might be true, but when n, you can find counterexample. When n is 120, right? 120 times 120 is definitely less than 120 to the 120. So this is false. You can find counterexample. Okay, next you have, for all integer x, there exists an integer y that y equals to 2x. True? Yeah, you just, for every x, there exists a wage. So you just set y equals to 2x. So this is true. Okay, so here you're asking which of the following statement is not a proposition. If you look at the first one, the integer n is divisible by 3. You don't know what's a value for n. So you know this is not a proposition. N greater than negative n for all integer n, this will be a proposition, since even though we don't know what's a variable n, but you have a quantifier for the propositional function. Once you add a quantifier, then your statement becomes a proposition, right? Because then you will be able to find the truth value for it. 2 is the smallest prime, right? This is true. All integer greater than 0 are even. We know this is false. Or you can find counterexamples. So this is a proposition. October 12th, 2021, it's on Thursday. I believe this is false. It's on Tuesday. But this is a proposition. It's always false. It gives you a specific date. There it says an integer n with 13 prime factors. Again, you see you have a quantifier. There exists. So they are all proposition except the first one. Okay, so here you want you to use the De Morgan's law to find which of the following statement is equivalent to it's not true. So you want to negate the employee receive a large bonus or the employee receive a large bonus and has big office. So you want to negate that, right? So you can think of it as like P and Q. So you want to negate P and Q relation. So you need to negate both and then change the N to or. So you will have, if you look at it here, employee did not have big bonus, so you negate the P, but you did not negate the Q. So if you look at next one, the employee received big bonus or big office, you only change the N to or, but you did not negate each part. So the correct answer will be the employee did not receive big bonus or does not have big office. So there is an or relation there. Right, so you negate both part and then change the N to a or. Okay, here's another induction question. So again, we will start with the basic step. And since n is positive integer, n will start with 1. Now n start with 1, well, when you plug 1 into n, you will get 2. So you know you will end there at 2. So you have 1 plus 2 is equals to 1 times 2 times 1 plus 1. And that will give you 3 equals to 3, which is true. Okay, so we passed the basic step. Now again, we will have the inductive step. So you need to make inductive hypothesis. You will assume 1 plus 2 plus 3 plus 4. Keep adding until 2k is equal to k times 2k plus 1. For k, positive integer k, so for k greater or equal to 1. Or you can just say for k, for positive integer k. And then you want to show 1 plus 2 plus 3 plus 4 plus 2 times k plus 1, it will be your last term, and that will equal to k plus 1 times 2 times k plus 1 plus 1. Now, if you look at it here, right, this is what you're trying to prove. Now, if you get the term before 2k plus 2, so if you look at it, 2 times k plus 1, you can simplify to 2k plus 2. And then on the right hand side, you have 2k plus 1, then you have 2k plus 2 plus 1, so you have 2k plus 3. Now we want to get some previous term. Right, so we want to rewrite this so we can have the inductive hypothesis appear. So we want to have 1 up to 2k term, but now we have up to 2k plus 2. Now, if you look at the theory here, you increment it by 1 each time. So the term before 2k plus 2, it will be 2k plus 1. And then the term before 2k plus 1, it will be 2k. So you know here, from 1 up to 2k, you know this by inductive hypothesis. This part is equal to k times 2k plus 1. Right, so this is from the inductive hypothesis. You know, from 1 up to 2k is equal to k times 2k plus 1. Now you need to show the left-hand side equals to the right-hand side. Well, here you will have 2k squared plus k plus 2k plus 1 plus 2k plus 2. And then the right-hand side, you will distribute k plus 1 times 2k plus 3. Then you will have 2k squared plus 3k plus 2k plus 3. Now, if you look at the left-hand side here, you have 2k squared plus, you have k plus 2k plus 2k. So you have 5k. And then you have you have 1 plus 2, so you have equals to 3. And then the right-hand side, you have 2k squared. And then you have 3k plus 2k, so that's 5k plus 3. So you show that left-hand side equals to the right-hand side. Any questions here? Okay, so here you have a propositional function. So Pn, where Pn defined as if n is a negative integer, then n is greater than n cubed. Now I ask you to determine the truth value for P120. Is it true or false? Right, it will be true. Right, so the statement only saying tell you what happens if n it's negative. It doesn't tell you when n is positive, so it's always true. Okay, and here it asks you to determine the truth value for the projection P, X, Y, Z, where it defined to be it would define as x plus y squared equals to z squared. Now, if you look at P 1, 2, 4, so that would be, you will check it's 1 plus 2 squared equals to 4 squared. So you have 3 squared equals to 4 squared. Well, it's false. Right, so the truth value is false. Any questions here? Is there any question on this exam? I see people asking, what's the total point there? This exam is out of 100. So expect your grade to be out in a day or two. So once your grades out, you should be able to review your exam by clicking the exam score, I believe. But you need to wait until the grade to release in order to review your own exam. Okay. So if there's no other question, we will end it here and we will start new topic next Tuesday. There is partial correlate for the long answer, but it depends on is your answer on the right track. Okay, again, the partial credit will depend on your work. So when you see your exam score, you should be able to view your exam, and you will also be able to see the score breakdown. Okay, everyone, have a nice weekend.